Show that the equation of any circle passing through the points of intersection of the ellipse is shown can be written in this form. Okay, well I think a good shout is to first of all find the points of intersection. Now what I notice is that I've got an x term, they're quite different, but the y squared terms are quite similar. And if I multiply my first equation through by 8, then I'll get 16y squared in both equations. And then we can subtract them, or make 2y the subject, whichever you prefer. Sorry, 16y squared the subject. 18 times 8, well, we can double 18 to give 36, double it again to give 72, double again 144. Can never remember, I should try and remember that one. 18 times 8, same as 12 times 12. And we'll just write the other equation alongside. So now let's subtract them. These cancel, and we're going to be left with, if I do 44 minus 25, think about why I add on to 25 to get 44, it's going to be 19, so 119. Right, let's expand and simplify. So 8, okay, I'll just deal with the bracket first. You can try and do it all together, but it's better to be safe, I'd say. X squared plus 4x plus 4 minus 9, x squared minus 2x plus 1. That gives 8x squared plus 32x plus 32 minus 9x squared plus 18x minus 9 equals 119. The 8x squared minus 9x squared becomes minus x squared. 32x and the 18x become plus 50x. The 32 minus the 9 becomes plus 23. And I'll make it so the x squared is positive. X squared minus 50x, and then 119 minus 23 gives 96. And let's try and factorize it. So factors of 96, well, 1 and 96, but that's, first of all, when you combine them, you're going to get an odd number, and also they're quite far apart. But if we go with 2 and 48, then it will work if we make them both negative. So x minus 2, x minus 48 is equal to 0. So that means x is going to equal 2 or 48. Let's find the corresponding values of y. We can put them back into either equation. I'm just going to go with this one because I don't have a 9 there. It just looks slightly simpler. Okay, so I'm going to put 2 in. I'm going to get 4 squared, so 16 plus 2y squared is equal to 18. 2y squared is 2, so y squared is equal to 1. Y is plus or minus 1. Two possible solutions. That's going to give us the coordinates 2, 1, and 2, minus 1. What happens with 48? Let's take a look. We're going to get 50 squared, quite big, plus 2y squared is 18. And that means that 2y squared is going to be less than 0 for sure, because 50 squared is going to be really big. And that means there's no real solutions here. Okay, so the only ones we're interested in are 2, 1 and 2, minus 1. We're trying to show now that a circle passing through these points of intersection has to be written in this form here. I'll just make a note of it. The ellipses are really out of the picture. It's all about the circle and the fact that it's got to go through 2, 1 and 2, minus 1. Okay, so a general circle can be written as x minus a squared plus y minus b squared is equal to r squared, where the center is AB and the radius is r. So if it passes through 2, 1, and 2, minus 1, then we can sub our points in. We're going to get 2 minus a squared plus 1 minus b squared is equal to r squared, and then 2 minus a squared plus minus 1 minus b squared equals r squared. And I can just set the two equal to one another, the left-hand sides, because they're both equal to r squared. Again, I haven't expanded it. You can expand it if you want. And what's going to happen is that these terms are going. So I've just got an equation involving b. There's different things you could do here. You could square root, but I think then I'd have to start thinking about plus and minuses. So I'm just going to expand it. 1 minus 2b plus b squared must equal 1 plus 2b plus b squared. Note, by the way, if you have minus 1 minus b squared, it's the same as if you have 1 plus b squared, because you're just squaring the negative. And when you square minus 3, you get 9. If you square 3, you get 9. So you can just make it all positive if you want. These are going to cancel. The 1s are going to cancel. We're left with 4b is equal to 0. Therefore, it's necessarily true that b is equal to 0. Now, I've focused purely on doing this algebraically, but it also intuitively makes sense. We need it to pass through 2, 1, and 2, minus 1, so here and here. So because a circle has, lots of symmetry to it, like it's got to kind of come round like this. Okay, it doesn't quite look like a circle, but you can see that the center is going to have to lie along the x-axis, and that's why it's going to be that the b is going to have to be 0, because then the center will be somewhere along the x-axis, but at y equals 0. Okay, so hence we've got x minus a squared plus y squared is equal to r squared. And I'm going to substitute back in. I'll use the point 2, 1. This time I'm not going to set them. I mean, I'm basically taking this equation and just setting b equal to 0. But I'm just going to do it from the beginning again. So 2 minus a squared plus 1 is going to equal r squared. And actually that means we've got a value of r. It's in terms of a, but that's okay. Hence, x minus a squared plus y squared is going to equal 2 minus a squared plus 1. I've just taken my general, well, not my general equation, but my new equation would be equal to 0, and I've substituted my new value of r in that we found. Now in the final answer, here it is, they've expanded the brackets. So that's all we've got to do and show that we can get this. So x squared minus 2ax plus a squared plus y squared is going to equal 4 minus 4a plus a squared plus 1. The a squareds cancel, so x squared minus 2ax plus y squared is therefore going to equal 5 minus 4a. Brilliant. Just before I finish, I'd like to show you the equations. So here we go. We've got the red ellipse is the first one that we dealt with, and the blue one, the second equation. And we can see the points of intersection, 2, 1, and 2, minus 1. The equations are very much like the equation of a circle, but you end up kind of multiplying terms by different amounts to basically get a stretch in either the x or y direction. And that's why it differs from a circle. You obviously get a different thing going on because you don't have a constant radius, but you have other properties as well. I'm not going to go into it here, but they have the whole area of mathematics. Um, Here we go with the circle then. This is when a is 1, and and you can see that it necessarily goes through those points of intersection. That's what we found out. Actually, to be fair, we started with the points of intersection and then found that that was the form that we had to have it in. But I'm just now showing you for different values of a that it does indeed go through the intersection. Here, as I make a bigger and bigger, it just gets larger here. Okay, make it smaller again, and it kind of like swaps around, make it 0 and then negative, and it ends up over here. So just wanted to share that at the end. Yeah, nice question.